We started life about 4 years ago, effectively in the consultancy of delivering drones. So our engineers and pilots was where we really grew from. But fundamentally, in the middle of 2022, we were asked by the UK Ministry of Defence to actually look at designing and developing complex systems. So what you can see behind me is effectively the culmination of 3 years' work, and they kind of span across everything from an avionic delivery solution to gas turbines, which we now build, and two of the newest products that we have on the site are just over my right-hand side here, the gas turbine, and that is a 50 kilonewton thrust. And we have got 3 products that are starting to develop at the moment. So the first one is hitting the streets in 12 weeks, which is the 50. And the bigger ones is a 110 kilogram thrust engine, really coming up with a 12-month program to deliver a 3.2 kilonewton thrust engine, which is largely made of 3D printed parts, which we hope to have under test in the next 6 to 9 months. What I've got behind me is the latest generation of one-way attack drones. It's a 250 kilometer range. It integrates a number of third-party technologies, but the fundamental bits are we build most of the microelectronics ourselves. So the gas turbine, the fueling system, the pressurized fueling system, and the payload are all things that we're able to complete in the UK. Really well though, we work with global suppliers. We have got a Turkish Toolcom 8200 system that's currently sitting in the nose cone. We also work with an American firm for the integration of their radar altimeters. But that platform with that equipment gives us unparalleled results, certainly in areas of operation that they need to be used in. So for example, it operates at nearly 500 kilometers an hour. It goes for a range of 250 kilometers. It terrain follows, so we'll sit at 50 feet above the ground and then skim the terrain until it gets close to its target point. And when it gets to its target point, it then pops up, reducing its radar cross-section to then actually have the impact that we need it to have. It's currently sitting with 3 variants. The first one is the standard static target defeat profile. The second one is an electromagnetic head, so it locks on to jamming frequencies and then is able to target them. The third one is a surveillance package, and that surveillance package really, it flies parallel to the area of the action, at which point it can then detect the kind of emitters that we're expecting and then build that into a target profile. And the final one, which is in development at the moment, is the integration of a long-range artificial intelligence head. Effectively then it can prioritize and detect targets at range in order then to categorize them against a threat target profile. It sits on a thing called a ROTAS. Now we call it the ROTAS Ant, which effectively is its launch dolly. And that launch dolly will take it from 0 to 60 in 1.4 seconds to then give it the rotational speed it needs, making sure that we can take off in 120 meters. But we were asked by a number of clients whether we can configure it for catapult launch. So the next generation you see behind me has got all of the systems being hardened so that we've got a catapult launch solution, an air launch solution, and also a ground launch solution using our ROTAS dolly.